Hello students, welcome back to CLARI Concepts, Unleashing Conceptual Learning. Today we are going to solve several numerical examples based on fluid properties. Now I would request you, if you are unable to understand, if you have came to this lecture before going through the lecture of fluid properties, I request you to kindly go through that lecture first and then come back here so that to get more clarity on numerical examples. Now here I would like to share some of the tips that you should follow always while solving numerical example. See, when a numerical example is given to you in form of exam paper or in some sort of objectives, this is actually a real practical life situation given to you, because nothing is hypothetical, right? We are all learning engineering. So what you need to do is you need to understand that you need to imagine the situation given to you, and then you need to make a call that which particular law, which particular principle, which particular formula is going to be applicable for this particular problem. So let us start with the first numerical that we have today. Calculate the specific weight, density and specific gravity of 1 liter of liquid which weighs 8 Newton. So let's say, for example, you have been given a liquid in a beaker, for example, and the liquid is filled up to certain height, let's say, and the volume of this liquid given to you is how much? 1 liter. Volume given to you is 1 liter, let's say. And the weight of this fluid is what? The weight of the fluid is 8 Newton. Now what they are asking you is, they are asking you to find out specific weight, this is number 1, density number 2 and specific gravity number 3. Let us start our solution. So the data given to you is volume and weight. Now firstly, if you want to find out specific weight, that is gamma. We all know gamma is equal to what? mg by v. So this is the amount of weight per unit volume. Now mass we are aware with. So if I have weight, can I get the mass? So already weight is given to you. There is no need to find out again mass. So this is nothing but W divided by volume. W is given to you 8. What is volume? Now volume given to you is in liters. Now you have to convert this volume in liters into meter cube. So as I said you, whenever you convert this, you have to divide by 1000. While going from liter into meter cube, you have to divide by 1000. This is 1 by 1000 meter cube. This is again 0.001 meters cube. So I'll put 0.001 meter cube. And this means what? The value is 8000 Newton per meter cube. This is the answer. Answer to first question. Now, second is density. Density rho. So how will you get density? Density is nothing but mass by volume. Now you all know that if weight is given to you, can you find mass from weight? Yes. What is that? If I divide weight by g, I will get mass, because weight is mass into g. So your mass will be weight divided by g, and 1 by v you had as it is. So why? Because we know that mass is equals to w by g. Now you have all the answers. You have weight to be 8 Newton, you have g to be 9.81 and you have v to be 0.001. What is the answer? Let me calculate. This is 8000 divided by 9.81 directly. This will give you 815.49 kgs per meter cube. So density of this particular fluid given to you, a liquid given to you is 815 kg per meter cube. Now, the third question. What is third one? Find out the specific gravity. Specific gravity. That is Sg. How do you get this? Sg is equals to density of the liquid divided by density of standard liquid, standard fluid. So this is the liquid given to you. So your standard fluid should be water. So Sg is nothing but, you have 815.49 divided by 1000. So Sg will be 0.815 and let's say 9. The answer. Sg is unitless, right? This is answer number 3. So you got all the 3 answers. I hope you got how to calculate the answer, how to calculate numericals of this particular topic. Let us take another example for more clarity. Now here it is said that calculate density, specific weight and weight of 1 liter of petrol of specific gravity 0.7. So let us say what is the given data to us. We have been given a petrol whose volume is 1 liter. Now when I say 1 liter, it means what? 0.001 meter cube. Okay. And specific gravity of petrol is given to you as 0.7. Right. Now they have asked you to find out density. So first is density. Density of oil. So you know that if Sg is given to you, that is density of petrol plus density of water divided by density of water. Why? Because petrol is in liquid form. Right. So now if I want to find density of petrol, that is Sg into density of water. Sg is what? 0.7 given to you. And density of water, normally it is 1000 kg per meter cube. You always have to remember this, right? Many times in numerical you will not be given this. If you do the multiplication, you will get 700 kg per meter cube. This is answer number 1. Density. Now second given to you is specific weight. Specific weight is gamma. Specific weight is symbolically represented by a symbol gamma. And we know the formula. Gamma is also equals to, because we know it is weight, that is mg by v, right? That means if I put it like this, m by v into g, I can say gamma equals to density into g. M by v is density. So if I want to get gamma, I know density. I can just multiply it by g to get the answer. So this is 700 into 9.81. This will give me 6867 newtons per meter cube. Answer number 2. I hope you are getting the clear idea of how to solve the numericals. Then finally, the weight of the fluid, weight of 1 liter of petrol. If you want weight of 1 liter of petrol, that means you must have mass of that and then gravity. Now if you want mass of 1 liter of petrol, now see, you know density, right? Density is mass by volume. So what is mass? This is density into volume. Let me put it like this. Density into volume into G. Density of the petrol is how much? 700. I will put it 700. What is volume that you are looking for? 1 liter. 1 liter is how much? 0.001 meter cube. 0.001. And what is G? 9.81. So this is somewhere around 6.867 Newton. So answer number 3. 6.867 Newton is the weight of the petrol whose volume is 1 liter. So I hope you got this right. Let us move ahead with another example, the final one of this lecture. Calculate the volume of the crude oil in liters that weighs 12 Newton and having density 970 kg per meter cube. You have been given 2 things. What is the data given to you? Data given to you, one is the weight, that is 12 Newton, weight of the crude oil, and density given to you is 970 kg per meter cube. They have asked you to find out the volume. So they say that if the weight of the crude oil that they have is 12 Newton, what is the volume of that? If density is this much, right? Now how do you calculate volume from density? We know that if I have density, I can say this is mass by volume. So if I want to calculate volume, I need mass by density. Density is given to me, I just want to have mass. How do I have mass from weight? Very easy. Volume is equals to, what is mass? Can I say mass is nothing but weight by G into density as it is, 1 by rho as it is. Why? Because we know weight equals to mass into G. So mass will be weight divided by G, simple. So what does it mean? It means that volume is equals to weight divided by rho into G. Weight is given to you 12, rho is given to you 970, G is known to you 9.81. What is the answer? Let me calculate. 12 divided by 970 divided by 9.81. I think you are getting 0.00126 meter cube. But this is not the final answer. Why? Because you have been asked in liters. Now when you want to convert the value in liters from meter cube, you have to multiply by 1000. 0.00126 into 1000. This will give you liters. So what is the answer? This is 1.26 liters. Now this is your final answer. Clear? So I hope you keep on doing this example in the same way. Hope to see you soon in the next class. Thank you so much.